Today we're going to talk about the sum and difference formulas. Now when we talk about this, we're really talking about in terms of the trig functions when you have a sum of angles or when you have a difference of angles. And we have a formula for the sum and difference of sine, cosine, and tangent. So let's start off with the sine formulas. So the sum of two angles that are inside the sine function, so let's call them u and v. So sine of u plus v is equal to sine of u times cosine of v plus cosine of u times sine of v. The difference formula is going to be sine of u minus v, and this is almost the same, except that instead of a plus sign in between, you have a minus sign in between. So this is sine of u times cosine v minus cosine of u sine of v. So those are the sum and difference formulas for sine. Now we'll move on to cosine, the sum and difference formulas. So let's start with the sum. So the sum of angles u plus v inside of the cosine function is equal to cosine of u, cosine of v, minus sine of u, sine of v. The difference of two angles inside the cosine function, this is almost the same, except instead of a minus, now you have a plus. So cosine of u, cosine of v, plus sine of u, sine of v. And lastly, we have the tangent sum and difference formulas. These ones involve a fraction. So tangent of u plus v is equal to tangent of u plus tangent of v, all over 1 minus tangent of u, tangent of v. And then the difference formula for tangent is tangent of u minus v is equal to tangent of u minus tangent of v, all over 1 plus tangent of u, tangent of v. So you'll notice with all these formulas that the difference between the sum and the difference formula within each trig function is just a matter of the sign. So for sine, you can see instead of a plus, it's a minus. For cosine, you see the minus becomes a plus. And then for tangent, in the numerator, the plus becomes a minus. In the denominator, the minus becomes a plus. But everything else stays the same. Now we're going to look at some examples where we actually use these formulas, and you can see how they can be useful. So in example 1, find the exact value of cosine of 75 degrees. Now we're not going to use a calculator to do this. In fact, we are going to try to break down 75 degrees into special angles that we do know the values of. And we can then apply either a sum or a difference formula to that. So for example, 75 we can break down into 30 degrees and 45 degrees. Those are values that we know the cosine of. So I'm going to write this as cosine of 30 plus 45. And now you want to look at the sum formula for cosine. And we're going to go ahead and apply it. So this is cosine 30 times cosine 45 minus sine of 30 times sine of 45. And now for each of these, you know the exact values. So cosine of 30 is root 3 over 2. Cosine 45 is root 2 over 2. Sine 30 is 1/2. Sine 45 is root 2 over 2. And now we can go ahead and simplify this as much as we can. We'll try to leave our answer as an exact answer so we won't come up with the approximate answer by actually taking the square root of 3. We'll just simplify as much as we can. So we have square root of 6 over 4 minus square root of 2 over 4. And since we have the same denominator here, we can actually combine it into one fraction and say that our answer is the square root of 6 minus the square root of 2 all over 4. So you can see that even without a calculator, you can come up with an exact answer if you know, if you're able to break down an angle measure into angle measures that you do know the sine or the cosine or the tangent values of. So this was in degrees. Let's look at an example where we're working in radians. So find the exact value of sine of pi over 12. Now I saved this one to be the second one, even though we have been working in radians, because it's a little harder to think about how we can break down pi over 12 into a sum or a difference. So on the side over here, I'm going to write down all those values of angles that we do know, and I'm going to write them next to their equivalent with a denominator of 12. So pi over 2, we know that value, so that's the same as 6 pi over 12, pi over 3, same as 4 pi over 12, pi over 4, the same as 3 pi over 12, and pi over 6 is the same as 2 pi over 12. Now, if you're looking at the right-hand side of all these equations now, you want to see, is there a way for me to either add or subtract two of these in order to get pi over 12? Now, there are, of course, multiple ways to go about this. For example, you could do 4 pi over 12 minus 3 pi over 12, right? That would be pi over 3 minus pi over 4. You could also do 3 pi over 12 minus 2 pi over 12 to get pi over 12, so that would be pi over 4 minus pi over 6. So there are multiple ways of going about this. Neither way is wrong. You should end up with the same answer. I'm going to go ahead and use pi over 3 minus pi over 4. Now we can apply the difference formula for sine. So this is sine of pi over 3 times cosine pi over 4 minus cosine pi over 3 times sine of pi over 4. And since we know all these values, we can go ahead and substitute them in. So sine of pi over 3 is root 3 over 2. Cosine pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2. And sine of pi over 4 is root 2 over 2. Okay, so as we simplify this, let's see, we have square root of 6 over 4 minus square root of 2 over 4. And we can combine that, since we have the same denominator, write it as one fraction, so the square root of 6 minus the square root of 2 all over 4. Now you might be wondering, well, isn't that the same exact answer we got in example 1? Do we always get that? No, you don't always get that. The reason why this happened to be the same answer is, think about what pi over 12 is in terms of degrees. Pi over 12 in degrees is 15 degrees. Now, since in example 2 you were finding sine of 15 degrees, well, remember that there is an identity, a cofunction identity, that relates sine and cosine together, right? So sine of x is the same as cosine of pi over 2, which is 90, minus x. What's 90 minus 15? 90 minus 15 is 75 degrees. So that's exactly why we know that they are supposed to be exactly the same. It's not that anytime you use these sum and difference formulas that you get the same answer. Okay, let's take a look at example 3. This one's a little different. Find the exact value of sine of u plus v, given that sine of u is equal to 4 over 5, where u is between 0 and pi over 2, and cosine of v is equal to negative 12 over 13, where v is between pi over 2 and pi. Okay, so the first thing we're going to do is, you can think about, well, okay, sine of u plus v. What do I need? I need sine of u, I need cosine of v, I need cosine of u, and sine of v. What do we have? Right now we have sine of u and cosine of v given to us. But we still need to know what cosine of u and sine of v are. But we can find what those values are from the information given. So start with the sine of u equals 4 over 5. This information, we're also told, is in the first quadrant, right? U is between 0 and pi over 2, meaning it's in quadrant 1. So in quadrant 1, if we are working with sine of u equals 4 over 5, now 4 over 5, that should ring a bell to you. It's a Pythagorean triple, a 3, 4, 5 triangle we're working with here. So cosine of u must also be positive, and it must be equal to 3 over 5, right? X over r. With cosine of v equaling negative 12 over 13, and you're told that v is between pi over 2 and pi, that means we're working in quadrant 2. Now in quadrant 2, now we want to know what sine of v is equal to. In quadrant 2, we know sine is going to be positive, and the 12 and the 13 indicate to us that we're working with a 5, 12, 13 triangle. So sine of v is going to equal 5 over 13. Okay, now we should have all the information we need to plug things in. So sine of u is 4 over 5, cosine of v is negative 12 over 13, cosine of u 3 over 5, and sine of v 5 over 13. Okay, so now we can multiply those fractions. So we have negative 48 over 65 and 15 over 65. And we are going to go ahead and add those together, and we will get negative 33 over 65. Let's do an example involving tangent. So simplify tangent of theta plus 3 pi. So even though we have a value that's theta, we can still plug that in and see how much we can simplify it using the sum formula. So we have tangent of theta plus 3 pi is equal to tangent of theta plus tangent of 3 pi, all over 1 minus tangent of theta times tangent of 3 pi. Now think about what tangent of 3 pi is equal to. Tangent of 3 pi, if you draw for yourself a diagram, or you look at the unit circle, you are looking at the far left of the unit circle. Remember, tangent is equal to sine over cosine, and since the coordinates over here at 3 pi are negative 1, 0, this is going to be equal to 0. So that means that this becomes 0, and this entire thing here becomes 0. So now all we have left is tangent of theta over 1, which is equal to tangent of theta. And that's as simplified as we can get with this example. We have one more example. Solve sine of x plus pi over 4 plus sine of x minus pi over 4 equals negative 1 on 0 to 2 pi. So basically all your solutions between 0 and 2 pi for x. Now for this problem, what we're going to do is we are going to go ahead and apply the sum and difference formulas for sine to this equation. It's going to make it much longer at first, but we will end up seeing how that's going to help us simplify the problem. So let's go ahead and write it out. So this is going to be sine of x cosine of pi over 4 plus cosine of x sine of pi over 4. So that's the first part. And then apply the difference formula, and that would be sine of x cosine of pi over 4 minus cosine of x sine of pi over 4 equals negative 1. And now you'll see that we have a cosine x sine of pi over 4 and a minus cosine of x sine of pi over 4. So that's going to cancel. And now we're left with sine of x cosine pi over 4 and a sine of x cosine pi over 4. Well, that's the same thing. We have two of them. So let's combine those, and we have 2 sine of x cosine of pi over 4 equals a negative 1. Now we want to try to isolate that sine of x as much as we can and simplify anything else that we have. So start with that cosine of pi over 4. That's equal to square root of 2 over 2. And then here the 2 will cancel. And that leaves us with sine of x times root 2 equals negative 1. We still want to get sine of x by itself, so we'll divide both sides by the square root of 2. And that leaves us with sine of x equals negative 1 over root 2, or, in other words, negative root 2 over 2 if we were to rationalize that denominator. Now we can work with that. We're working with a reference angle of pi over 4. Sine is a negative value, which means we must be working in quadrant 3 and quadrant 4. And so in quadrant 3, that would be 5 pi over 4, and in quadrant 4, that would be 7 pi over 4. And those are the answers between 0 and 2 pi.